Hello everyone, my name is Justin Arrival. This is my Lab 3 Black Hole in Orbits for class Physics 2210. Lab setup. For this lab we use GlowScript to model both parts. Part 1 is finding the mass of a black hole by analyzing a star motion around the black hole. Part 2 is about orbiting and not crashing a spaceship. The goal is to put a spaceship into a figure 8 orbit around both the planet and the moon of that system. Next, the what does it mean question is how the net force and its parallel and perpendicular components are different from the rate of change of momentum in its parallel and perpendicular components. The what if question is to predict the motion of an entire system, what will you need to include in the computational model? The fundamental principles used in part 1 are Newton's law of universal gravitation, where F equals gmm divided by r squared. We use this to describe the gravitational force between the black hole and the star based on the distance r from each other. We also use this principle to estimate the mass of the black hole by using m equal fr squared divided by gm. And we also use Newton's second law of motion to update the velocity and position of the star while it orbits and the centrifugal motions of the star. Alright, now let's go over the code that was used to find the mass of the black hole. First, the while loop was used to run through each data point in the star trajectory. The rate controls how fast the simulation ran. Then we used the momentum calculation to find the initial velocity and final velocity of the star. Next, using that information, we found delta T over delta T, which is net force. Then, using that information, we estimated the mass of the black hole using the magnitude F net times R magnitude squared over G times the mass of the star, which came out to be 7.70029 E plus 43 kilograms. The fundamental principle used for part 2 is Newton's law of universal gravitation, which is F equals G times mass 1, mass 2 over R squared, which is every object with mass attract every other object. Newton's second law of motion, which is F net equal mass times acceleration, where acceleration is equal to F net over mass. This is used to find the ship and planet and moon, then update the velocity and position. Then also 3 body interactions. There's 3 objects that are interacting with each other in this part. It's the planet, the moon, and the spaceship. Alright, now let's go over the main part of the orbit and don't crash code. First, we gotta find the net force on the moon. We do this by finding the distance vector from the planet to the moon, calculating the gravitational force from the planet on the moon, find the distance from the ship to the moon, then calculating the gravitational force from the ship to the moon. And using both of those, we find the net force on the moon. Now we repeat the same steps to find the net force on the ship. The initial velocity for the ship is unknown to make a perfect figure 8 between the planet and the moon. We will explain more on the next slide. These images are my best attempt to get a perfect figure 8 around the planet and the moon. The moon orbit is the blue line, the spaceship orbit is the pink line, and then the blue dot in the middle is the planet. As you can see, I can sometimes get to orbit both the moon and planet sometimes, but not perfectly to be able to make a figure 8. Alright, let's go over what does it mean question. Rate of change of motion is how the star momentum changes over time, which is found by P final minus P initial over delta T. The parallel component is the rate of change of the momentum. Parallel tells us how the momentum is changing. And in the particular one, it's the rate of change of the motion, and the particular tells how the trajectory occurs. Alright, let's go over the what if question. To predict the motion of the full system, the model must include the gravitational force between all the objects, the black hole, the star, the planet, and the moon. And then also use Newton's second law to compute the motion of each object while each step of them are moving to update the position and velocity using the timestamps. Possible sources of error. The first one is rounding and floating point precision using code. The second one is error in my own code. I double checked it, but you can never catch everything sometimes. And then also, we know the spaceship effect on the moon, which it does have an effect on it, but the simulation doesn't know that. Thank you for watching.